Welcome back. This is section 2 of day 1. We're going to be examining a specific type of pattern that we encountered on the first page called an arithmetic sequence. The definition for an arithmetic sequence is on the top of the screen and on the top of your packet of section 2. An arithmetic sequence is defined as a sequence with a common difference. When I hear the word difference, I automatically think subtraction. However, a difference could be positive and represent an increase. So I'm going to have to a little bit unlearn what the word difference means. If a difference is positive, that means we're having an increase. If we have a decrease, though, we're going to say that the difference would be a negative number or less than 0, and that will be a decrease. Arithmetic sequences have this common difference. So I want you to think of the difference as like a slope, a constant increase or a constant decrease. So I'm going to write constant increase / decrease at the top. Arithmetic sequences always have a constant increase or a constant decrease. If it doesn't, then it's just a different type of sequence that's not arithmetic. Here's a helpful tip. To find the difference, take any term and subtract it to the previous term. On the previous section, we talked about what we can do with our previous terms in order to explain a sequence or a pattern. So you would just take any term, and subtract the previous term. Well, the subscript for the previous term would be 1 less than the n. So you're going to find that a difference in an arithmetic sequence is any term minus the previous term. From here on out, this is going to represent a previous term, and this is the next term, the term immediately after that. The one thing I will tell you is that I always use the same variable for an arithmetic sequence. Instead of t's, from here on out, when I talk about an arithmetic sequence and a pattern that I know is definitely arithmetic, I'm just going to take away these t's like we saw on the first page, and I'm going to replace them with a's for arithmetic. This will help me distinguish one formula from the next. I'll just let that go into focus because my pencil kind of got it out of focus. There we go. So the t's have been replaced with a's when I speak specifically about arithmetic sequences. At the very next thing, what we're going to do is there are 4 examples. We're going to determine if each sequence is arithmetic or not. If it is arithmetic, we're going to find the difference of each sequence and find the next 3 terms of the sequence. So let's take a look at exercise 1. -7, -3, +1 and +5. Each term is increasing by 4. So what do you think? Is this one arithmetic? Yeah, I think it is. If I increase by 4, that means my common difference is 4. Then it asks us to find the next 3 terms. So 1, 2, 3, 4. The 4th term is 5. So the 5th term, I'm going to call that a sub 5. The arithmetic 5th term is 4 more than the previous term, or 9. A 6 would be 4 more than 9, or 13. And a sub 7 is 4 more than 13, or 17. Let's go across to question 2. 14, 35, 56, 77. Let's go back to the top. Another way we can do this is let's actually do the subtraction like they recommended. Take any term and subtract the previous term. Now the only term that doesn't have a previous term is the first term. So starting with the second term, let's subtract 35 minus 14. Let's subtract. I get a 1 and I get a 2. Is this increasing by 21? Let's take a look at the next one. What's 56? Subtract the previous term. Yes, that's also 21. This has to work for every pair of terms in order for us to say that it has a constant decrease. And what do you think? Well, yes, it does. Our difference equals 21. And since the difference is positive, we have an increasing sequence again that is arithmetic. Knowing that it's arithmetic, what I can do is I can write a sub 5, a sub 6, and a sub 7 and find their values. Once again, using the a's because we know this is an arithmetic sequence. So 21 more than 77 makes 98. 21 more than this is 119. And 21 more than this is 140. Let's double check that and make sure my math is right. So if I subtract 119 from 140, I get 21. If I subtract 119 minus 98, I get 21, so I think my work is okay. Let's go to the bottom. Exercises 3 and 4. Okay, this looks like it's a constant increase of 40. 40 more than 20 is 60. 40 more than 60, that's not 100. I'm not sure this is arithmetic. I don't think that it is. So we're going to write not arithmetic. We're going to skip this question. Not that it was an accident. We had some doubt whether or not it was going to be arithmetic. I think this is another pattern I do recognize, but we have a different name for that and we'll study it later. Question 4. Let's take a look and see if this is arithmetic. If I take the second term and I subtract the first term, I get negative 10. Subtract the third term minus the second term, I get negative 10. Subtract negative 19 minus a negative 9 is negative 10. Yes, this is arithmetic. The difference is negative 10. Find the next 3 terms in the sequence. 1, 2, 3, 4, so this would be the fifth term is 10 less than negative 19. The sixth term is 10 less than negative 29. And the last term we need to find is negative 49. Again, sequences are an ordered list of terms. They do have a beginning term, which we call that the first term. It doesn't have an ending term. This does go beyond the 7th term. This concludes our second section. You can pause the video and open, or actually you can close this video and open section 3.